Hello, welcome to Chapter 12, Lesson 2. Today we're going to be talking about drawing scaled picture graphs, also known as a pictograph. Okay, let's read this little guy down here. In grade 2, you use a picture graph with different pictures to represent data. A pictograph uses the same symbol to represent more than one. For this reason, it is also called a scaled picture graph. We'll get into it some more. So let's just get started here. Okay, so here's our first example. It says 15 students drew pictures of their favorite fruits on sticky notes. Their responses are shown in the picture graph. Okay, right? There's pictures showing which people voted for which ones, right? Picture graph. How can this data be displayed in a pictograph? Okay. So this is them. This is like kind of what we would call the raw data. This is just they voted, put it up there, done. So let's look at how we can make this cooler, more interesting with a pictograph. The pictograph displays the same data as a picture graph, but in a different way. So our scaled picture graphs need to have a key that says for each one of these symbols, this is a basket. Okay, so each basket equals 2 students voted for that fruit. Okay, and then so a half basket, if a whole basket is 2, then a half basket would be just 1 student, right? So if you can see here, if each one of these equals 2, there would be 2, 4, 6 people voted for banana. Is that true? 1, 2, 3, 4, 5, 6. Yes, that is true. And 4 people voted for orange. 2 people voted for strawberry. What? They're crazy. That'd be my vote. And 3 people voted for apples because there's 2, and then a half basket, which is a 1 person, which would be 3. Now, here's the biggest misconception I see a lot students fall into. Okay, they're going through their Scantron test and they got something like this and they say, oh, okay, 3 people chose banana, 2 people chose orange, 1 person chose strawberry, and one and a half people? What? How do you have half a person? 1 and a half people chose apple. So that's why it's always like they're just trying, this whole lesson is really making you know how important it is that you look at the key. It says each one of those pictures does not equal 1 student voting. It means 2 people. So that changes the data. So don't do this. Okay, this is bad. This is wrong. Don't do it. You need to look at the key to see how much each one of those symbols represents. There are half as many symbols in the pictograph as the picture graph, so the graphs displayed the same set of data 2 different ways. When you read a graph, you study or analyze the data. You are able to interpret the data or explain what you learned. Okay, so here we go. The pictograph shows the results of a survey Antoine conducted. Who saw 2 or more movies than Grace? So here it is circled. Okay, each ticket means 2 movies. So Grace watched 6 movies. Okay, I better follow the rules down here. The key shows each symbol ticket represents 2 movies. Grace saw 2, 4, 6 movies. Carla saw 2, 4, 6, 8 movies. Because each one is adding 2 to make 8 movies. So Carla saw 2 or more movies than Grace. Also, we could have said Zach. Zach saw quite a few movies. He's a movie buff. So did Ivan. So Carla, Zach, and Ivan saw 2 or more movies than Grace did. Analyze the pictograph, then write a sentence that interprets the data. Okay, so when we're analyzing a pictograph, here's what goes through my head. I read the title. 2 weeks of weather. Okay. So if I'm doing 2 weeks of weather, then I should have 14 days up there, I would think. Okay, so then I'm going to go down to the key. Okay, each smiley face means 2 days. Okay, so sunny, we had 6. 2, 4, 6 sunny days. Cloudy, we had 2. Snow, we had 2, 4. 4 sunny days. That does not quite add up to 14. I don't know where the other 2 days went. How interesting. Maybe there was no weather on those 2 days. Okay, so now we need to write a sentence that interprets the data. So that's where we could say the most common weather was sunny and the least common weather was cloudy. We could also say something about how there were 2 more sunny days than snowy days. There were 2 less cloudy days than snowy days. Or there were 4 less cloudy days than sunny days. Right? We're just kind of talking about what we're seeing on this graph here. Display the set of data in a pictograph. Write a sentence that interprets the data. Okay. The Delaney horse farm. These must be different types of horses. I'm going to say yes because I've heard of Clydesdales and Mustangs before. And the frequency. Okay. So we know that 1 horseshoe is equal to 4 horses. So how many horseshoes am I going to need to make 16? Let's see. 4, 8, 12, 16. I need 4 horseshoes to make 16. How many do I need to make? 8. 4, 8. We should try to make them similar in size, right? I don't want to have a tiny little baby one and then a big one because that's going to look like it's representing a different amount. Okay, so we want them all to try to be about the same size. And then a Clydesdale has 10. 10 is not a multiple of 4. So let's see what we'll do here. 4, 8. Okay, I need to add 2 more. 2 is half of 4, so I'm going to draw half horseshoe to represent 2. If the whole horseshoe represents 4, then a half horseshoe represents 2. Write a sentence that interprets the data. So another sentence I could write down is, how many total horses are at the farm? So 8 and 6 makes 14, 3, 34. So I could interpret the data by saying there are 34 horses at the farm. The Delaney horse farm. I could say they have mostly Appaloosa horses at their farm. I could say they have a few Mustangs. Mustangs are the least popular horse at their farm, right? I can make all these kind of claims about the information that I'm seeing. Understand symbols. A pictograph key shows 3 mountain symbols for 1 mountain range and 4 mountain symbols for another range. Each symbol represents 7 hikers in the mountains. How many hikers are in the mountains altogether? Okay, so they have 3. That's my quick mountains. Each symbol represents 7 hikers. Okay, 3 7s, 2 are worth 14, 3 are worth 21 hikers. The other one shows 4 mountain symbols, 2, 3, 4. So I'd get 7, 14, 21, 28. So that shows 28 hikers. How many hikers are in the mountains altogether? So I should add 1 and 8 makes 9. 2 and 2 makes 4. So there are 49 hikers. Make sure when you're doing this on your book that you don't forget your label. I'm noticing that's kind of becoming a common thing that we're forgetting our label. Okay, choose the correct words to complete each sentence. What is a picture graph? Well, there's only 3 and there's like a lot of them, so let's read the definitions first, I guess. To blank is to read or study the data on a graph. Okay, the blank in the graph tells how many each symbol stands for, so that'd be the key. Okay, I know that one right away. A blank uses the same symbol to represent more than one vote or tally. A pictograph uses the same symbol to represent more than one vote or tally. Pictograph. Okay, and if we're reading or studying the data, we're analyzing it. When we're making a claim, then we're interpreting it. So that one's analyze. Okay. Test practice. A pictograph key shows that each movie symbol equals 6 movies. How many symbols equal 18 movies? So really here we're doing 18 divided by 6, right? If I have 18 movies, I want to know how many. I'm going to put them into 6 groups. So if I'm counting by 6s, I would say 6, 12, 18. How many 6s did I need? 1, 2, 3. So I would need 3 symbols to show 18 movies. All right, that's all I have for you for today. Thanks for watching.